Okay, so this is the 2024 Higher Level Maths Leaving Cert Paper 2, question 7. So PK Hotels is a hotel chain in Europe. The ages of the people who stayed in PK Hotels in 2023 are roughly normally distributed with a mean age of 48.2 years, standard deviation of 10.6 years. One person is picked at random from the people who stayed in the PK Hotel in 2023. Find the probability that this person is less than 50 years old. So in this case we have our mean, our population mean, age of 48.2 years. We have the population standard deviation 10.6 years, and in this case our x value is 50. What we're asked to find here is find the probability that this person is less than 50 years of age. So what we want to do is convert this x value to a z value, a z-score. So that's going to be, let's see, it's going to be the x minus mu over sigma. So we want to find the probability that z is less than 50 minus 48.2 divided by 10.6. And that's the probability that z is less than, so you just need to work that out on your calculator. It's 0.1698. Now you can look that up in the tables. 0.1698 or 0.17 probably is the easiest one to look up. So let's see, we have 0.17 out here, which is 0.5675. I think that's all we had to do, find the probability. Yeah, so that's it. Okay, so let's move on then to the next one. Part 2, exactly 10% of people who stayed in a PK hotel in 2023 are at least A years old. Find the value of A correct to the nearest whole number. So if we just look at a standard normal distribution, got 0 here, and we're told that exactly 10% of people who stayed in a PK hotel are at least A years old. So 10% and at least is going to indicate that we're talking about this part of the graph here. So this is going to be my Z value here. I'll call it maybe Z1. And we're looking at this part of the graph here where 10% of people are at least A years of age. Now that means that 90% of people are down here, or 0.9 if you like. So that's the information we're going to use. So we want to know the probability that Z is greater than or equal to some Z value, Z1 I'm calling it, and we're told that that's equal to 0.1. Now that's going to be equal to the probability that Z is less than or equal to Z1 is going to be 0.9 or 90%, because currently it's at least, which means greater than, and it's easier, well, we can use less than from the tables, and we know it's positive because we're talking about 10% up here. What we've got to do is look for 0.9 in our tables, so let's have a go at that. So we want to find 0.9. The nearest we can get is 0.8997, and that means we're talking about a Z value of 1.28. So our Z value is 1.28, and how would we have worked out that Z value? Well, we would have taken the value A, we would have subtracted the mean, which is 48.2, that's the population mean, and we would have divided by the standard deviation. So remember, this is our standard normal curve with our Z, but the A comes into play from the original normal distribution, where the mean here was 48.2, and the A value is actually here. This A value corresponds to this Z value here, and your 10% is here, and your 90% is here. So this is your original normal curve, this is your standard normal curve here. So all we've got to do is solve for A. So what you'll find is you multiply across by 10.6, so we're going to bring that up here and multiply, and then we've got to add 48.2, and what you'll find is that the A is equal to 61.768. Now it says here A is correct to the nearest whole number, so we want A to be 62 years. And that's it for part 2. Let's move on to part B. So part B1. During their most recent stay, 1/5 of PK Hotel customers used the pool. Use this to answer parts B1 and B2. 6 of the PK Hotel customers are picked at random. Find the probability that exactly 2 of them use the pool. So really this is a Bernoulli trial. So the formula for that is n choose or, the probability of success to the power of or, the probability of failure to the power of n minus or. So that's the formula we're going to use. We did the trial 6 times if you like, because 6 of the customers are picked at random, so it's going to be 6. We want the probability that exactly 2 of them, so we want 2 successes, which is or. The probability of success, the probability of using the pool, the probability of success is 1/5. That's going to be to the power of 2. The probability of failure not using the pool is going to be 4/5, and that's to the power of n minus or 6 minus 2, to the power of 4 in other words. So all you've got to do is just work that out. You get 768 over 3125, and that actually ends up being a terminal decimal 0.24576. Okay, so next one. N of the PK Hotel customers are picked at random, where n is a natural number. The probability that none of them use the pool correct to 4 decimal places is 0.0047. Work out the value of n. Okay, so again we're using this formula, n choose or, probability of success to the power of or, probability of failure to the power of n minus or. So in this case we have n customers are picked at random. We want the probability that none of them use the pool, so 0 goes there. Probability of success is 1/5, that's the power of or. 4/5 probability of failure to the power of n minus 0, which is just n. We are told that this probability is 0.0047. So all we've got to do is solve this for n. Now n choose 0 is just 1. 1/5 to the power of 0 is just 1. So really what we end up here with is 4 over 5 to the power of n. Or really I should write that maybe as 0.8, it might be easier. 4/5 is just 0.8 to the power of n is equal to 0.0047. So a couple of ways of proceeding from here. You can get the log of both sides and bring the n down, or we can just rewrite it in log form. So we'll rewrite it in log form. So log to the base 0.8 of 0.0047 is equal to n. So 0.8 to the power of n will give us this here. Now, so this is index form, in other words, this is log form. So really all we've got to do is type that into the calculator and we will get an n is equal to 24.02127, but it's really just 24 because we're told that n is a natural number, so n is going to be 24. Okay, so that's it. Let's look at the next one, part C. So PK Hotels are testing a new booking form. 45% of people who log on to the PK Hotel website are shown the old booking system. The other 55% are shown the new booking system. People are assigned the booking system old and new at random. 1/3 of people who see the old booking form end up booking a room. 2/5 of people who see the new booking form end up booking a room. One person is selected at random from those who booked a room through the PK Hotel's website. Find the probability that this person uses the new booking system. Give your answer as a percentage, correct to the nearest percent. Okay, probably the easiest way of describing this would be to look at a tree diagram. So let's take the old system here, the new system here. We were told that 45% of people who log on to the PK Hotel's website are shown the old booking system. So this is going to be 0.45. So down here this must be 0.55. 1/3 of people who see the old booking system end up booking a room. So they're going to book a room. These are not going to book a room. So this is 1/3. and this must be 2/3 here then. And just further down we've got new system, so again they're going to book or they're not going to book. So in this case 2/5 of people who see the new booking form book a room. So this is going to be 2/5 here, and this is going to be 3/5 here. We have everything we need, I think. There are only two things really that we need to work out here, because we are asked to find the probability that this person used the new booking system and this person booked a room. So really we just want to look at booking a room, these two parts here. So I'm going to multiply 0.45 by 1/3. This is the old and booking. This is the new and booking. So if we multiply 0.45 by 1/3, that'll give us the probability that the person looked at the old system and booked a room. So multiply those two together, you get 3/20. The probability that the person looked at the new system and booked a room would be 0.55 times 2/5, and that is 11/50. That's really all we need here. So if you read the question, it says one person is selected at random from those who booked a room through PK Hotel's website. Find the probability that this person used the new system. So really this is a conditional probability type question. Really the question is find the probability that this person used the new system given that they booked a room. So again you just apply the formula here. So it's the probability of new intersection booked divided by the probability of booking. So we just stick in the numbers here. We've got the probability of new intersection booking is 11/50. That's 11/50. Got to divide that by booking. So what's the probability that a person booked the room? It's just going to be these two here added. So it is 3/20 plus 11/50. And that's really it, that's your answer. We just got to work all that out. And if you do that, you get 22/37. So the question actually says, give your answer as a percentage correct to the nearest percent. So if you just work that out as a percent multiplied by 100, that to the nearest percent is 59%. Okay, so that's that one finished. Let's go again. So part D then is an hypothesis test. So we have in 2020 PK Hotels were rated the best hotel chain in Europe by 75% of their customers. In 2024 PK Hotels carried out a survey of a random sample of 1,000 of their customers to see if this percentage had changed. Of these, 765 rated PK Hotels the best hotel chain in Europe. Carry out a hypothesis test at a 5% level of significance to see if it shows a change in the percentage of their customers who rate PK Hotels the best chain in Europe. State the null hypothesis, alternative hypothesis, conclusion, and a reason. Okay, so let's just write down what we're given first of all. We're given that the population proportion P is 0.75. That's this value up here. The sample is 1,000. And then it says, of these 765 rated PK hotels, the best hotels. So that is going to be our P hat, which is 765 divided by 1,000, or just 0.765. Now we've got to carry out an hypothesis test. Now because this is a proportion type question, the only way we can do this in this course is to do a confidence interval. So let's do that. The confidence interval is going to be population proportion is less than and greater than or equal to P hat minus 1.96 times the square root of P hat times 1 minus P hat over n, and P hat plus 1.96 times the square root of P hat times 1 minus P hat over n. So in our case we have P hat as 0.765. We've got to subtract 1.96 times the square root of 0.765, 1 minus 0.765 divided by 1000. Same on the other side, but this time we're adding, so it's going to be plus 1.96 times the square root of 0.765, 1 minus 0.765, all over 1000. So all we got to do now is just do these calculations. So it is P greater than or equal to, less than or equal to. When you carry out these calculations on the left hand side, you get 0.7387. On the right hand side, you get 0.7913, let's say. And that's it. That's our confidence interval. Now the question says, state the null hypothesis, which we have not done, so I forgot to do that at the very beginning. So our null hypothesis is that P is equal to 0.75. The alternative hypothesis, which is H1 here, is that P is not equal to 0.75. So that's our null hypothesis and our alternative hypothesis. Then it says state your conclusion and give a reason for your conclusion. The confidence interval that we got is this one here, 0.73 or 73.87% up to 79.13%. The 75% is within this interval, so therefore there hasn't been a change since 2020. So that would be our conclusion. So let's just write all that out. Just come over here. So I'm going to say that 0.75 is within our confidence interval. At a 5% level of significance. Therefore, we fail to reject the null hypothesis and conclude that there has been no change in the percentage of their customers who rate PK hotels the best in Europe. Okay, so that's really it for this question.